All right, so welcome everyone to the 8th General Body Meeting of ACM for 2021. It's February 4th. If you haven't checked in, check in there. So as always, you're being recorded, and we've got all of our past meetings on our YouTube channel, and our slides are also in our archive, so you can go check those out there. ACM UC, I hope you know by now, is the Association for Computing Machinery, Computer Science and Programming at UC. We all love it. All majors are welcome. We have all these kind of events, especially RevUC coming up in 2 weeks. Please sign up for that, where's our slide? There we go. Revolution UC, 24 hours, coding, learning, and fun. It's going to be a great weekend. Lots of sponsors, prizes, swag, fun mini events like Bob Ross painting, all kinds of stuff. So please sign up. Everything the whole event's free, so sign up at revolutionuc.com. And let's go back here. So membership requirements, you don't have to buy any ACM membership. Just join our Slack and Discord, and you're in pretty much. Code of conduct applies in all of our everywhere where we communicate, Slack and Discord, and in meetings, of course. So basically just a harassment-free experience for everyone. Be cool. So like we've been having at all of our meetings this year, raffle, we'll draw for that at the end of the meeting. Since we can't have pizza in person, we're going off of whoever checks into this meeting, you get entered in the raffle and you can win a gift card. So check in to attendance if you haven't yet. RevUC, Slack, it's our main form of communication. You can sign up there. And Discord, we've used for social events and stuff. Office hours, we've got started up. Our first one is tonight, right after this meeting. We'll just be chilling there talking about any of the cool talks that we see tonight. And there's a link to join Discord on our website. And yeah, I mentioned the archive resources. Anything else, you can find our schedule of future meetings on our schedule on the website and our YouTube channel. And then upcoming meetings, in 2 weeks at 7 p.m. again. We've got a guest speaker who's doing work in software in medical devices, so that should be super interesting, like a industry professional and kind of a different tech aspect. So that's super cool. All right, so let's get to the main event because we've got 6 people lined up, as long as we've got everyone here. All right, so we're missing at least one speaker. So we'll hope he comes in. But yeah, so basically lightning talks. We've got some people we've got some fun topics. Just crank them out in 5 minutes or less, and then we'll have about 3 minutes for questions, general discussion, whatever. And then we can move on to the next one. So this should be fun. Anything anyone say or any questions before we jump right in? Or was I just glitching for this whole last 5 minutes?
No, you were mostly good. I think it's going to be a weird night, though.
All right. Man, right before this, I was in the cloud computing class, and we were using Azure for stuff. Hope that our class didn't crash Microsoft.
Too many server requests.
Yeah. All right. Well, there's no questions. Yeah, I'll hand it over to Baru. I'll stop sharing my screen, and I'll pick it back up when I'm up in the slides. So yeah, whoever's up can share their screen. Yeah.
So it looks like I'm first. Okay. Give me one moment just to get my thing set up. Screen share. Find that. What are you guys seeing? Is it the second thing, or is it like the small or the big? What are you guys seeing on your side?
I see black.
I don't see anything right now.
Coming up. Yeah.
Black screen.
Black screen. Oh man. Sharing is paused until you return to the video. Okay, so terribly sorry about this. Oh, I think I know what I should do. Screen one. Do this. Swap. Does that look good?
Yep, there we go.
And can everyone hear me all right?
Yep.
Yep.
Sounds good.
Awesome.
Yep, perfect.
So glad that that's out of the way. But just to introduce myself quickly, my name is Baru, and today I'm going to be talking about the Fibonacci sequence and how you might implement it in Python. So just a little refresher on the Fibonacci sequence. It's a sequence formed by, for a given number in the sequence, you get to it by saying, you calculate it by saying you sum up the previous few numbers. So if you think about 0 and 1 at the beginning, those are kind of given because there's nothing previous to those. And then the third number in the sequence, that second one, we get that by adding 0 plus 1. Those are the numbers previous to it. And then that can go on for infinite series, and then you can see how it goes from here. So to generalize it in math terms, you can simply say this. So if we're looking for the Fibonacci number, the 0th number in the sequence, then that's always going to be 0. And looking for the first number of the sequence, that's always going to be 1. But in any other case, we're going to be looking for f of n, being Fibonacci of n. We're looking for f of n minus 1 and f of n minus 2. So if we have this kind of mathematical understanding of it, it's actually really easy to translate it into some working Python code. So here is what a really simple implementation of Fibonacci is. So it's a recursive function actually, and we say for Fibonacci of n, if n equals 0, return 0. If n equals 1, return 1. Else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. It's you can see easily how it translates from the math version to code. So what's going on under the hood though? So here is actually a Fibonacci tree that represents a calculation sequence for a Fibonacci. So if I want to try to calculate Fibonacci of 5, I need to know n minus 1, which is Fibonacci of 4, and as well n minus 2, which is Fibonacci of 3. And you can see how each of these Fibonacci calls is calling more calls. And this is kind of leads you down to a kind of a bad problem actually. So if you notice, these red boxes, they represent Fibonacci of 3 calls, and we're doing that twice. And these blue boxes, they're Fibonacci of 2 calls, we're doing that 3 times. So that actually means that for each Fibonacci call, there's 2 calls, and that's O to 2 of n power, which is really, really expensive. So here's what this looks like on a graph. If you look at the x-axis, that represents a given n, and the y-axis represents how many calculations you'll be doing on average. It gets really costly to calculate even a really large number. Say I wanted to do Fibonacci of 100, that's going to be, really high up, and that's going to be way too expensive to calculate. If you're going to pull this up in an interview, for example, you will probably be receiving an L. So how can we optimize? What are some things we can observe to try to get to a faster solution? So we need to understand the first thing is, if I calculate f of n, that's never going to change. So if I do f of n and I calculate that at one point, and then I do a bunch of other calculations and come back to that same f of n, I should always be getting the same answer. So that never changes regardless of what we do outside of the scope of Fibonacci. So if I've already calculated it once, why should I have to calculate it again? I showed you guys those boxes, right? We're doing multiple calculations of the same exact thing. We're wasting time. So instead what we can do is we can store values for later to reuse. So also, it looks kind of like this. So say I store, if I want to get Fibonacci of 5, that gets me to Fibonacci of 4. That means that biologically speaking, I need to do Fibonacci of 4. And then I'll store Fibonacci of 3. And then on the right side of the tree, you can see Fibonacci of 3. And instead of having to pull it out, or instead of having to do the whole tree again, I can just pull back my old value. So instead of looking like a tree, it starts to look more like an array or a Fibonacci sequence, if you may. So here's what that code will look like. It actually looks really similar to the code I just showed you, except we introduced this idea of a memo. So this memo is a map or a set structure in Python. And basically at the very beginning of the function call, we're going to say if n in memo, we return memo of n. And near the bottom before we return, we want to say memo of n equals Fibonacci of n minus 1, n minus 2. And only then, once we memorize it and we store the value that we've calculated at that point, that means that we don't have to go through the whole tree again. So think about it this way. If I'm going to do Fibonacci of 4 and then I have to calculate Fibonacci of 4 again, it's just going to do that first return statement rather than do the whole Fibonacci calls at the bottom where we're doing that tree branching out, and that wastes a lot of calculation time. So looking like this, if I'm going to calculate the second number in the array, I can just immediately go back. And that actually gets us to O of n time versus O to the 2 of n time. Really, really, really good algorithm, actually. So this is what that looks like on the graph. So generally speaking, almost a 1-to-1 ratio in terms of n input and n amount of calculations. That's a pretty good dub right there. So the moral of the story here is that the Fibonacci sequence can be optimized with dynamic programming. And dynamic programming is a fancy word used for a really simple concept. It's identifying a recurrence relation, meaning a repeated action, and avoiding wasting calculation by figuring out when exactly to reuse values and how exactly to store the values. And now you can say you know dynamic programming. But that's all for the talk. Thank you.
Awesome. Thanks, Baru.
Thanks, Baru.
Are there any questions?
Yeah, question.
Yeah.
Sorry.
Sure.
So if we were to use dynamic programming for Fibonacci numbers, can we also use that same method for factorials or finding powers of a number? Can we use the exact same method, or we'd have to reiterate the method too?
Let's think. Factorial number. No, not necessarily. Not anything that I can think of, because the thing about dynamic programming is you have to identify a recurrence relation and you have to be doing something repetitively. So the thing about factorials, you're doing 5 times 4 times 3. You're not repeating a calculation that you've done previously. You're just doing a new calculation that you haven't done before. So I don't think there would be a way. Maybe there is a way that I'm not aware of, but nothing that I'm aware of for factorial. You said another kind of method. I don't remember which it was.
Taking the power, but I guess that would fall in the same.
Power of a number? No, I don't think so either, because again, it's just like if you get like 3 times 3 to the third power, you're doing 3 times 3, it's 9, and then you do 9 times 3 is 27. You're doing a different action that second time. So not that I'm aware of, but maybe there is something out there. A common like question, I guess it's like the next step for this, would be the climbing stairs question, where say you're given a staircase of 8 steps, and you can climb it by climbing 1 step at a time or 2 steps at a time. And how many different ways can you climb the staircase? That's a really common question that revolves dynamic programming. So if you want to look that up, look up climbing stairs problem. It's a cool one.
Nice.
I guess the way it can help in like factorials is if like you're running the same algorithm multiple times. So the first time you run it, it'll take the full time, but the next time you run it, it can use the stored values. So I think that was what was in mind for the question.
Okay. Got it. Cool. Anyone else?
All right. Well, it looks like our next speaker's not here yet, so we'll see if he hops in before the end and we can let him go. But yeah, thank you, Baru. And if Natalia, if you're ready to go, you have the floor.
All right, let me share this screen of mine. All right. Wait, let me see if I can also turn on my camera. Can I be seen? I can. Sweet. All right, I put on a button up just for this. So this is going to be worth it. All right, let me pull up this script. All right, so got 5 minutes. All right, I'm here to talk about the Agile methodology. Okay, first of all, my name is Natalia Louie. My major is in computer engineering, and I am a first year, but I have used the Agile methodology, so I am slightly qualified to talk about this method. So we're going to talk about what a development cycle is, what are methodologies and how they work, and why are we going to choose Agile. So what's a development lifecycle? It's a fancy word for just saying it's a type of methodology that with clearly defined processes for creating high quality software and hardware with the lowest cost and the shortest time needed. It focuses a lot on requirement, like figuring out what you need for the project, planning through it, software design, software development, and then testing it, and finally deploying it. So that's why it's called development, because develops things. So there are two main methodologies of doing development lifecycle. So you have the waterfall development and you have the agile development. So waterfall is more old school. A lot of companies have been using it for many, many years, as long as the company's been alive. But agile has become a bit more recent. I'd say in the past 30, 50 years, it's popped up and it's really useful. But right now, I'm just going to tell you the differences between them. So in waterfall and in agile, you have your requirements. So someone just plops down a problem and says, how do I do this? Second, even though agile says it's plan, it's different from how waterfall says design. Because in waterfall, you have to design the actual product, and then you code it, and then you test it, and then you implement it, like a waterfall. But in agile, you plan out how you're going to design it. So it sounds a little counterintuitive, but trust me, it really helps. Because when you're working on a brand new team with new people, you don't know how they work. You don't know how you're going to go through this process. So planning out how you're going to go through all the stages of making this product will help you work on designing it, then developing it, and then releasing it. So there's a reason that Agile says release and Waterfall says implement, okay? Implementing means immediately putting the product out into the world and saying, start using it, you know? But in Agile, they release the product for feedback. That's why on number 6, you see track and monitor, where they get the feedback, and then in like a circle, the way Agile is, they reiterate and refine the product until they get exactly what you need. So why are we going to choose that? Well, I feel like I already explained why we're going to use Agile. But there's also Agile is not just the circle. There are other different methods of Agile. And if I had more time, I would love to talk about them all. But right now, I'll just tell you that there's like Scrum, where there's roles assigned to people. There's Kanban, where there's just a bunch of tasks, and everyone just has to see what tasks there are, what tasks to work on, and what tasks are finished. There is Lean development, where it's just imagine waterfall, but you're trying to slim down the amount of time and resources you're going to need for that. So depending on what you need to emphasize in your team and in the business, you can choose a different agile methodology that would work really well for you and your team. So as you can tell by the big companies have been using this. So Apple, Microsoft, IBM, Procter & Gamble. And as you can tell, they've been pretty successful with it. They come out with new and exciting technologies that we all get to use and play with and make really cool things out of it. But, not everything is perfect. So are there any drawbacks to Agile? And there is. I would say it's a very important drawback because I already mentioned how many different varieties of Agile there are. But the problem is there's too many. So, for example, our team and I tried using the Kanban method where, hold on. So we had like this. We had a list of things to do, a list of things that we had to work on, and a list of things to finish. But then we realized this doesn't really work out for a team because none of us are punctual. So we changed to a different method called Scrum, where we have someone as the lead developer, someone as a lead designer, or the one who designs the hardware of the product, and then someone as a product owner. Product owners, they just communicate between who needs the product and how we're going to be able to do it. And therefore, we all had someone to watch over us as we did our work because we were not punctual. So that's why, am I at 5? Oh, I'm at 5 minutes. It's too late now. So that would be the drawback of Agile. So in other words, you just have to really research the types of methodologies there are to know which one works for your company, or else you're going to be wasting time and money and resources and all that. But I'd like to say that Agile just fuels innovation through communication. The whole point of Agile is that you have a team of people who communicate with one another and are very cross-functional. So not only can the developer design something, but your product owner can also develop. And that's the whole point. So you're going to learn together, you're going to innovate together, and you're going to communicate together. Thank you. I think I talked too much. Any questions? While I exit this screen.
Hi. So I'll quickly just mention one thing about Agile. I really like Agile methodologies and everything, but I always say that there's obviously it's because it's like complicated, it's heavily misunderstood often, and there's like it's so easy to like get Agile wrong.
Oh,
and do
yes.
everything like in the wrong and just go down the wrong path, and it just seems very counterproductive sometimes. It's just very
Exactly.
difficult to pull off. Would you agree that that's a big disadvantage of Agile?
Yeah, I would say if I had like more time, I would say that that was really important, because I know another team of mine, we used Agile as well, but we used the method of Kanban where we had too many tasks to do, and we didn't have enough time and not enough people to get through them all. So it just didn't work out for us, and we had to move back and think about, should we even use this method? We did find a different type of method of Agile to use, and honestly, I think the fact that Agile is just hard to understand just helps, so long as you research it and you experiment with different types of it. I think that just makes up for the lack, but it's rough the first time you use it. Yeah. Are there any questions? Because I think that was a lot of information. Let's see. Hope you liked it.
Yeah, that was great. Thank you.
No problem.
You're definitely the most knowledgeable freshman on Agile that I've ever met. So
I took 2 courses.
okay.
That's
I can tell you
impressive.
that much.
I was gonna say
You
a
don't
lot
have
of
to
us know about
specify.
Agile at this point, but for any freshmen here, like that was probably super informative. So
Yeah.
Yeah.
It's not just freshmen. If you're expecting graduates to know what Agile is to its core, it's not going to happen.
Oh well,
it's a
yeah.
good point. Yeah, not to the extent you know it. Yeah.
All right. Well, I just educated you all on Agile. Go do your own research. You're gonna do great. Yeah. Next one.
Do
can
they
go.
teach this stuff in computer science? Like, do they have a methodology class?
Yeah,
course?
in the software engineering class, which is like 2nd or 3rd year. Yeah.
Yeah, I'm taking one right now in IT. It's pretty fun.
Nice. It's a really cool course. Oh.
All right. So I think. All right, then I guess I'm up next. So. And I think it's just been my end glitching. Has anyone else been experiencing a lot of glitches?
I see it now. It was okay
Looks
before
fine.
this.
As soon as you said that, you started
Oh,
glitching a
great.
lot. Oh.
Of course, right as I start talking. Oh, man. Okay, well, if I start glitching out, yell at me to go back. All right. So, my name is Brandon, and I'm going to tell you how to get from point A to point B. So, you have point A, you have point B. You draw a straight line between them, right? Wrong. So, in some cases, maybe you can draw a straight line, but as you can see in this picture, I don't know why they did that, because there's a lake in the middle. So in real life, there's going to be obstacles in your path, and you can't just draw a straight line from one point to another. So unless you're some kind of Looney Tune who can walk through walls or bulldoze through any obstacle in your path, you're going to have to find another solution. So in real life, we are looking for a path from point A to point B all the time. So maybe it's late night, you're craving Chipotle, and Google Maps is going to route you a map. So it's going to take you around all the buildings and roads and get you a perfect path. So the underlying concept behind Google Maps and all of those different route makers is pathfinding algorithms. So pathfinding algorithms, one of the most simple ones that you'll ever learn, one of the first ones you'll learn, is breadth first search. So we'll start with this one. And so in order to embody breadth first search, I want you to imagine that you are a higher level being, a higher level consciousness who has the ability to feel their surroundings with their mind and spread their consciousness around them incrementally. So you kind of imagine this as like you're starting in one location, and then you slowly spread and feel around you, feel, until you find that Chipotle with your mind, right? So you can see this in action. So basically, you're starting at one point, and basically at each square you visit, you're gonna look all around you and say, have I been to that square yet? And if not, you're gonna go to that one next. And so, and then basically you just avoid walls, and you continue to expand outward until you find your goal. And that is that. But as you kind of saw, you're checking every single square. So that'd be a better way, right? There is. A-star pathfinding algorithm is a much better solution. And for this one, I want you to first imagine that you're playing your favorite game, maybe Skyrim, maybe another game, and you've got that compass up at the top. And so there's something marked on your map that's telling you where you want to go. So in A-star pathfinding algorithm, you have this heuristic function, which acts sort of like a compass. It basically tells you, you can kind of call it on each possible step that you could take, and you could basically figure out what's my next best step to take, kind of like a compass. And so you can see here, instead of just going out aimlessly in all directions, searching for the goal, it's more directed. So it's going down and to the left, and then going around walls where needed. So it's much more efficient. So here's some more examples. And so this one, you can see it kind of hits a giant barrier, but then it eventually makes it around, and then it sees, okay, I need to go back up and to the right, up and to the right. And then this one too, I like that goes in a little zigzag. So yeah, it's much better, much more directed, and it can handle many different situations and still find the shortest path from point A to point B. So yeah, that's all I have. Did I glitch out for anything and you want me to repeat anything? Otherwise, that's the code. I did a little project last summer, and that was the visuals you were seeing. Yeah, any questions?
I have a question. So your username is B Star. I didn't know if that was a play on A Star. Just wanted to clear the water.
Yeah. Yep. Good catch. I mean, kind of. Yeah.
Or is that just an unintentional? Is that unintentionally what it is? And since I came up with it, you're like, that sounds cool.
No,
I'm gonna go with it.
I was typing it in, and I was. As soon as I typed it, I was like, hey. So yes.
Yeah, pretty interesting. Do you plan on like making a Minecraft bot with this pathfinding algorithm that can just like search places, give you the best paths to something? Sounds like a pretty nice application of this.
That's true.
Actually, if you don't mind me commenting on that, I believe I saw this video Minecraft a long time ago, and if you remember Minecraft, the zombies can chase the villagers, and someone placed like a rat in a maze almost, and like they put the villager on the outside, the zombie in the middle, and it actually just found the fastest path. I think that was just programmed into the game already.
Oh wow.
Yeah.
That's pretty nice. But there's also some mods that allow you to like have machines that you can code in Lua, like in Minecraft. So you can. Sounds like a pretty good.
That's
nice summer project.
Stays on plain level, right? What about like for scripts that want useful for the that are useful for the player, like that just mine diamonds automatically?
Yeah, there are turtles that do that. It's pretty interesting. Awesome.
All right. Well, unless there's any other questions, we can hand it over to Dave for. Is that right?
Yep. Let me share my screen.
Okay, I wasn't sure what you were laughing at.
I'm laughing at the chat.
Okay. All right. Well, take it away, Dave.
Thank you. So my lightning talk is Intro to PWAs with Service Workers. I am Dave Agrawal. I'm a third-year IT student. I'm a webmaster here at ACM, and I work as a software developer. My socials are listed here on the slide. The slides will be shared after the meeting. So first of all, PWA. PWA is an acronym for Progressive Web Applications. These are apps that combine the best features and advantages of native apps and web apps. As you can see here in the slide, in the diagram, native apps have more capabilities, but web apps have better reach and can be discovered much easier thanks to search engines and stuff. So progressive web apps achieve this by basically letting you create installable web applications, and then you continue using them like a native app. Here you can see some screenshots of how you can install web applications on desktop and on mobile. So service workers are at the core of PWAs. These are basically scripts that run in the background, and they provide most of the capabilities that native apps have. Capabilities like push notifications, caching, background sync, and also the ability to use your app offline when you're not on the internet. You can see here how a service worker does, how you can use a service worker to display a notification, and also how service worker interacts with the cache so that you can use your app offline. So how does this work? Service workers have an event-driven API. What this means is that service worker basically reacts to various events that happen in the browser. These events can be lifecycle events, which I'll talk about it in a minute, but most of the time you will be listening for the user events. For example, the fetch event is triggered when the application makes a request to the server. Here, the service worker can basically intercept that request and return a cached response instead of making the network request. This saves a lot of time of having to fetch a file or some data from the internet over and over again. So the first time the user requests some data or some file, you can just use the service worker to cache it, and the next time you just serve it from the cache. Push event is how you send notifications. So we saw it on the last slide, how you can send a push event from the server to your service worker. And then the service worker reacts to that event by creating a notification on the user's phone or desktop. Sync event is used to synchronize between application and server. I'm not going to go into too much detail about sync and message because they're not that much used, but they definitely exist and are useful to some extent. Messaging is used to communicate between your main application code and the service worker code. Because they run on separate processes, separate threads, they don't have access to the same memory, so you won't have the same variables available. So message is how you communicate between the two. Notification click is what happens when the user clicks on a notification. So for example, if you showed a notification to the user about them receiving a message, so when they click on the notification, you want to open the chat screen, and this is how you do it. If this is a lot, that's fine, because service workers, you don't actually need to know all of this to use a service worker or to write one. It's just, I'm just dumping a lot of information so that like I can educate you all and then you can research. The next important thing to know about service workers is a life cycle. Because service workers are background processes, they have a life cycle that we kind of need to care about. So the first step here is registration. This is where the browser asks the user for permission to install the app, like we saw in the screenshots a couple slides ago. When the user grants the permission or clicks on the install button, your service worker is now successfully registered. Then the browser downloads the JavaScript file that was registered and installs it as a service worker. That's the installation step. Finally, it activates the service worker, and then it can start responding to all these events that you can program in there. Now, service worker is just the background script that you write. To use its capabilities to the full extent, you need to use it in conjunction with some other APIs that are available to you in the browser. These are used for some very specific things that you may or may not need for your specific use case. These are APIs that you can also use outside a service worker in your regular JavaScript code, but using them in a service worker is what really gives them the feel of a native application. Fetch and cache usually go together. Fetch API is used to make HTTP requests and get files or data from the server, and cache API is used to store those files locally and then access them and give it back to the user, like I mentioned earlier. Push API also, I mentioned earlier, it's used to listen to various events from the server that you can then send from your server to the user. Channel messaging, also I mentioned earlier, is used to communicate between the service worker and the main JavaScript code. IndexedDB is basically an entire database available to you in the browser on the front end. And Sync Manager, also I mentioned earlier, is used to synchronize data between app and server. Here's a list of resources that I often refer to when I'm working on progressive web apps for service workers. I highly recommend you giving them a read. Also, if you're interested in PWAs or any kind of front-end development, you can always reach out to me on the socials. And if you guys have any questions right now, I guess we have 2 or 3 minutes to take them.
Hey, Dave. Thanks. That was a nice talk. I wanted to know more about the notification click that you talked about in probably the second slide.
Notifications, there we go. Right, so basically there is this API called Web Push, which is implemented by all the major browsers. You can create a push subscription on your browser. Usually we do that in a service worker or the main JavaScript code, doesn't really matter. And then once that subscription is created, you can store that in your server, in your database. And then from your server, you can send a specific message to that subscription, and that message is then received in your service worker. So a lot of the stuff here is happening behind the scenes. Go ahead.
Yeah, nothing. That makes sense.
Okay. Yeah, it's kind of hard to wrap our head around. I also struggled with it, but it's only because like there's a lot of things that happen behind the scenes that like the browsers have already implemented that like it doesn't immediately it's not immediately obvious of how much work the browser is doing for us. But yeah, that's basically how we do it.
Cool. Thank you.
Any other
question? Considering service workers and information like data about a user or how long they've like been on a website or a server, how long is that information stored in a cache or in a database? Is it stored forever, or is there an expiration date, or does it just depend on the person who made the API?
Good question. So yeah, it's pretty much stored forever until the user manually goes and like clears cache and the application data, or until like you update it from the service worker. So for example, when you're caching files and stuff, you can have versions. So if you go back to your server and update a file, you can give it a new version number, and then on the service worker you can check if there's a new version available, and then you can update the cache. If you don't do that, it will probably be in the cache for an indefinite amount of time. And if there's something defined, it's browser specific. So different browsers may have different limitations on how long something is stored. Does that answer your question?
Yeah, it does. I'm just also thinking about the cybersecurity of it too.
I mean, this has existed for a long time, and it's pretty secure. And you're not really storing any sort of sensitive data. If you are, then that's probably. I mean, you're always going to store some sensitive data like a token or session stuff, but it's like always there.
Oh, is it?
Usually it's stored in cookies. Here you can store it in databases and cache.
Ah, so is the information automatically encrypted, or do you have to write that in the code to encrypt?
Yeah, it's. I guess maybe the browser encrypts it. I'm not sure about that. But if you like really want to secure it for some reason, then yeah, you can write encryption.
Cool. Nice presentation.
Thanks.
Awesome. Thanks, Dave. And it looks like we've got time for our final presentation, Piyush.
All right, I'm gonna try sharing my screen now. All right, you see it?
Yep.
All right, cool. So, hi, my name is Piyush. I'm a third year computer science. I'm secretary for ACM at UC this year. And this is getting started with Discord.js in 5 minutes. I'll try my best. And if you're wondering what happened to my hair, it's just I've been wearing beanies a lot, so it's in a bow cut right now. But anyways, to get started with Discord bots and other applications, you'll need to create an application on the Discord developer portal. So if you go to discord.com and discord.com/developers, you'll see a button which says new application. You click on that and you start an instance of an application at that point. The next step is to create a bot user. What the bot user basically does is handles the application that you just created, and then you can customize it to your own liking. This is the kind of screen that you'll see. There's a lot of settings over here. Authorization, authentication, bot. There's rich presence if you want to integrate your games and stuff into it. But we're interested in the bot section, so you can choose the name of your bot, a profile picture maybe, and configure different settings if you want. But the most important thing here is the token. The token we'll talk about it later, but this is what identifies your bot. The next logical step is to invite the bot to your server. So you go into the authentication tab, choose the scope for your bot and the bot permission, and it generates a URL for you. You go ahead and copy this URL, post it on your web browser, on the address bar, and follow the steps, and that's it. That's the entire setup, and now you can start coding your bot and program it to whatever, however you like it to be. I'll be using Node.js, but you can also do it in Python. And there's a lot of bot commands that you can program using Node.js. For example, sending an initiation message, or sending a message to a channel, reacting to a message, tagging a user, responding to them, or even adding or removing roles. So I'm gonna skip back here to my code for a second. So as you can see here, I'm assuming that you have Node.js installed in your computer, and Discord.js is an NPM package that you can install easily. You declare two constants, Discord, and then you initiate a client. And once you start running this program, you'll be able to, once you start running this application, you'll be able to see that your bot goes online. So if you go to the server, this is my server, and you can see the bot is online right now because probably I didn't stop it, but it should have been offline. Anyways, so once you start the bot, it'll be on ready, and these are the functions that you need to that the bot will perform since I've coded these. This is the name of the channel. This is the code of the channel that I want the bot to send the message at when it logs in for the first time. And the token that I was talking about is used here. This identifies your bot and will send the message at the correct place, because your bot can be in multiple channels. And then you have to log in using that token. So let's start the bot. And it gives me a console log because I have this. Every server is a guild, and this is my server. So it gives me a feedback, and it says hello world, since that's what I coded in to say. So now let's go to bot commands. Bot commands are fun. They you can have a identifier for a bot command. In this example, I use exclamation points. And this message goes on after you receive any message with an exclamation point, it goes on to process this function. This is called process command, which has the message as the argument. And then I split the message into various parts. I remove the exclamation point. This is a substring from the first character. I use keyword. I use this list keyword to split the whole thing into different words. If you have a multi-word command, the first word in the whole thing will be the first word in the whole thing will be your actual primary command, and everything else will be arguments. So I have a few commands that I've coded in here. For example, if you want to send a message to a channel, you just do message.channel. It identifies which channel the message came from, and then be able to correctly send a response to that message. If you want to react, it's just message.react. And this is how you repeat a message by tagging a user. And if you wanna add or remove a role, you can have the role set up. These are all role IDs, and I have an if-else statement here, which is basically these are the arguments. If the argument is 1, it'll give me a role 1. If this is 2, role 2. This is the same thing over here. It's instead of add, I just remove the role. So if we test these out, if I type ping, since the bot is online now, I can test this out. If I do ping, the bot will say pong. I believe it's online somewhere else also, probably in my command prompt. Maybe that's why it's doing that. But anyways, it should be doing it twice. But this is the basic whole concept. I can give myself a role. For example, right now I have both the roles. I can remove the role by just typing this, and I don't have that role anymore. And I can also give myself that same role back by doing this. And so this is basically how you get started with Discord.js. It's hopefully it's pretty easy. It looks intimidating, but all you need to know is a little bit of JavaScript, and there's a lot of documentation out there. I'll put this code out if you want to look into it and get started with your own bot, but it's pretty easy. Thank you. If you have any questions now, you can go for it.
Yeah, I have a question. Would it be better to have one bot that does multiple tasks or multiple robots to do different types of tasks?
Depends on the application. Sometimes, okay, so there's usually what happens is there's one bot for mostly one thing. You can say you've seen music bots, which only play music. There's leveling bots, which level you up and have all kinds of statistics running in the background. But usually, I've seen most bots that I've seen only do one job. You can have a one bot do multiple things at once, but it can depend on the category of the bot that it's in. And it also depends on the application size, because sometimes even one job takes a lot of application space, and you need to keep this bot running. And possibly you're going to host it on Heroku or something. And so the application size matters. And that's why I think most bots serve only one purpose.
Okay. But they all have to be hosted on the same server.
Not necessarily. You can create a bot and put it out there. And like if the server can handle it, and if your bot isn't too slow, then for sure you can have multiple functionalities on your bot.
Thank you. Nice presentation.
Thanks. Anyone else?
So what are you doing with Discord.js?
Oh yeah.
Currently.
Oh yeah, I forgot to say that. Okay, I'm working with Discord.js to create a bot for Revolution UC right now, and it's gonna have some really perky features, kind of like we're gonna do check-in, leveling, and stuff like that. Also possibly a few other Easter eggs that you can try out. But yeah, I've been having fun with Discord.js lately, so I thought since I'm working with it, I might as well share it with you guys.
Are you doing it agile way or waterfall?
I think I'm the only one working on it. I don't know. You are also working on it. I think it's agile.
You're doing it your own methodology.
Yeah. Oh, looks like you have a question. Is there any advantage to using Node.js over Python?
It is, I guess, but it all depends on. I think it all depends on preference. All comes down to preference. If you're more comfortable with Python, then definitely. But I think Node.js is better because it has, like, you can work with NPM and have a lot of packages and a lot of other modules that you can install. And a lot of third-party applications. Like if you're doing a Discord bot and if you want to pull out web searches and stuff like that, then it's probably going to be easier with Node.js than Python.
Awesome. All right. Well, I think that concludes our last talk for the night. Thank you all to all of our speakers for joining us and coming up with those awesome presentations. Those were super entertaining. It was very fun.